trying to figure out at what rate is this angle changing at the instant that this is 6 feet away from the wall if the ladder is being pulled away or sliding away at 1 foot per second. So, what, again, mathematically do we have in which we would have theta involved? Trig, right? So, what trig function could we use here?
Opposite over hypotenuse.
We could do opposite over hypotenuse just as easy as adjacent over hypotenuse. We could do opposite over adjacent too. We've got all of this information. The problem with doing opposite over adjacent is that we have two sides that are changing. So in a lot of these triangle problems, when we're solving for angles, we're going to try to use the one that's not changing because it's going to make the arithmetic easier, actually, if we use the one that's not changing. So, if y'all want to do what's harder, we can do both of them, and we get the right answer eventually. So, you said opposite over hypotenuse to start off with, so what trig function does that deal with? Sine. So we have that the sine of theta is equal to the opposite side, and I'm going to put op in there, and I'm going to call that L. Well, opposite side, actually, let's just call that y. So it's y over L, right, for this drawing? Now, because this is a constant, I can automatically plug it in at the beginning of the problem. I can't plug in this 8 at the beginning of the problem because this is changing throughout the problem. This is not always 8, but the ladder is always 10. So I'm going to go ahead and make it 10. The sine of theta equals to y over 10, or 10 times the sine of theta is going to equal to y. And I'm going to pause right there and just make sure we're okay. Again, I've not done any calculus up to this point. This is as simplified as I'm going to be able to get it. So, let's start taking a derivative. What is the derivative of 10 times the sine of theta? 10 times the cosine of theta. All right. I'm not going to treat this as a product rule because it would be the derivative of this, which would be 0 times whatever that is. So I'm going to hold off on that. This is just constant multiplier. Constant multiplier, remember, says it's the constant times the derivative of the function. Is everybody okay here? All right. So let's keep going. Mary Virginia's agreeing with me. Well, that doesn't help my feelings any. So, say that again? That didn't help my feelings either. What now? Did I hear someone over there? Equals dy dt. All right. That is a derivative of y with respect to time, right?
Yeah.
What am I trying to solve for? D theta dt. Very good. It just so happens that I left a little space right there, right? Remember, the derivative of sine of an angle is the cosine of the angle times the derivative of that angle. Is that coming back to you now? Was it ever with you, so it can come back to you? You don't have to answer that out loud. All right, so let's start filling in what we know. All right, we've got 10 here, right? That's the hard one. All right, now, what is the cosine of theta? Yeah, but
6 over 10.
it's going to be 6 over 10 for this case, right? Because we already know that for this specific case. Now, I couldn't plug it in up here because the value of 6 was changing throughout the problem. But now that I'm at my derivative, I'm caring about this instant, so I can go ahead and plug it in. But let me put, let's do 6 over 10 because it'll cancel out easier. Okay, so we got 6 over 10 there, and d theta dt is what? That's what we're looking for, isn't it? And what is dy dt? It's negative 3/4, right? We solved that last time. That was not given in the original problem. If this problem had jumped off, and I hadn't even asked anything about that yet, and I just said at what rate is the angle changing, you'd have to go through and solve for dy dt in order to get there. So dy dt is negative 3/4. And again, that would be in terms of feet per second. I'm going to include units here. This is feet. This is feet over feet. And this is feet per second. So the 10's going to play with the dodo bird. So we've got 6 feet d theta dt equals negative 3/4 feet per second. Everybody still okay here? Okay. Still want to solve for d theta dt. So I need to do what here? Divide by 6, but I'm going to call it 6 feet here, just again for the purposes of the units, because I want you to see what happens with the units. A little bit different in this case. And instead of dividing by 6, I'm going to multiply by 1/6. Y'all don't have a problem with that, do you? Okay. So I get negative 3 over 24, which would simplify to be what? So I get negative 1/8. All right, now, what about my units here? The feet cancel out. So it's just per second. So negative 1/8 per second. No, it's negative 1/8 per second. Radians, you can put radians per second here if you want to. But mathematically, radians don't have units. Why is that? Why would radians not have units? What is a radian? Not always. It doesn't have to have pi in it.
It's like a fraction.
Could be. In this case, it is. But what is a radian? You learned radians in trigonometry, but what is a radian? Well, a radian,
Another way to measure degrees.
or measure an angle. Measure an angle, yeah. Be another way to measure an angle. But a radian comes from an arc length. And if I want to know what the radian measure of this angle is, it's equal to the ratio of the arc length to the radius. Now, what are my units for arc length? It could be feet, it could be anything, right? Yards, whatever. What would be my radius, my units for radius? Be the same thing. Whatever this is, whatever this is. So they would cancel out. So that's the reason why radians don't have units connected with them. Because whatever the units are here would cancel out with this. Now, 1 radian is when you have an angle and the arc length is equal to the radius. This happens about approximately 6.28 times per rotation. What's significant about 6.28? It's 2 times pi, right? So, this is good stuff. That all comes together. Y'all are going to be too excited to sleep tonight. So it's negative 1/8. You can say radians per second if you just don't feel comfortable about leaving per second as your units. But negative 1/8 radians per second or negative 1/8 per second is fine. This is approximately 57 degrees. No, that's not exactly right, but it's close to 57 degrees. If you take, someone do that real quick. Divide 2 pi by 360. No, 360 by 2 pi, sorry.
565.486.
Put 2 pi in parentheses.
57.29.
57.29 degrees, okay. I couldn't remember exactly what it was. So it's around 57.29 degrees is where 1 radian, where your radius is equal to your arc length. All right. So how do y'all feel about that?
Good.
Good.
It all comes together.